Over the past 80 years, white-tailed deer densities have exploded across northeastern North America. Ecologists and conservation biologists have documented the strong effects of deer browsing on ecological processes such as plant community assembly, forest soil development, and nutrient cycling. Recent work suggests that deer are also important agents of natural selection. Plants browsed by deer tend to be smaller, less likely to flower, and less likely to survive than those protected from deer. In theory, such effects on individual plants should lead to divergence in diverse traits among populations, including defensive traits. Defensive traits can be grouped into two broad categories: resistance traits, which reduce the preference or performance of herbivores, traits like spines, latexes, or secondary compounds, and tolerance traits, traits that allow plants to replace browsed tissue or reproduce after damage. Grasses, for example, are known to tolerate browsing by developing secondary growing points, tillers, and rhizomes. Often, in surveying areas that are heavily browsed by deer, one will find only a few resistant species that deer rarely eat. But there are a few palatable native wildflowers that persist in areas of high deer density. One such species is Impatiens capensis, or spotted jewelweed, a common wetland plant that has been used in a number of studies of local adaptation. The question then is, how do these species persist? In collaboration with Anurag Agrawal and Clifford Craft, I designed an experiment to test whether Impatiens capensis was an example of a palatable species that had evolved tolerance to browsing. Although deer are hyperabundant in New York State, they are not distributed evenly. Both land use and topography affect their distribution. This patchiness in deer densities allowed us to identify populations of Impatiens capensis that have experienced heavy browsing for the past 50 years, and those that have been sheltered from heavy browsing for the past 50 years. In the spring of 2012, we collected 100 Impatiens seedlings from each of 26 populations across New York State. 13 of these populations were historically browsed, and 13 were historically protected from browse. Historically protected populations were located in sites inaccessible to deer because of physical barriers such as steep slopes, fences, or dense urban development. The collection sites ranged from Central Park in Manhattan to the suburbs of Ithaca to the outcrops in the Catskills. The inclusion of many populations ranging from urban to rural and encompassing a variety of soil and shade conditions allowed us to focus on deer browsing history as the distinguishing factor. That summer, we established a common garden, planting 10 seedlings from each population inside a deer exclosure and 10 outside the deer exclosure in a balanced, randomized design. And then we waited for the deer. Deer naturally browsed all but 16 plants in the unfenced plots in early July. That May through October, we recorded growth rate, survival, browsing damage, date of first flowering, date of first fruit, and the positions of the fruits. We estimated an individual's fitness by measuring its lifetime seed production. We found that, on average, historically unprotected populations were more tolerant of browsing than historically protected populations. So on this graph, you see the mean individual lifetime seed production on the y-axis, by treatment on the x-axis, browsed or unbrowsed, and by history, with historically browsed populations represented as open diamonds and historically protected populations represented as black diamonds. In the unbrowsed treatment, there is no significant difference among populations with different browsing histories. deer browsing reduced mean lifetime seed production by 57% in historically protected populations, but only by 20% in historically unprotected populations. This was a significant difference. We then wanted to understand the mechanism of this tolerance, so we tested for differences by history among growth, architectural, phenological, and reproductive traits. What we found was that populations that were more tolerant to browsing in terms of seed production achieved this by increased flowering days and increased seeds per flowering node when browsed compared to when they were protected. To our surprise, none of the other variables were correlated with tolerance. So in summary, individuals from historically unprotected populations of Impatiens capensis were nearly 3 times as tolerant of browsing as those from historically protected populations. Of all the traits measured, flowering duration and number of seeds produced per flowering node were correlated with tolerance. Both of these traits could well be targets of natural selection in response to herbivory by white-tailed deer. Together, our results point towards 2 plausible historical scenarios. Either heavily browsed Impatiens capensis populations have recently evolved tolerance to browsing, or historically protected populations have lost the ability to tolerate browsing. In the past, we have assumed that rapid ecological changes like deer population explosion occur at too great a rate for species to adapt to them. However, recent studies show that insect herbivory can cause rapid evolution in only a few generations. Relatedly, evolutionary rescue, or a population's ability to avoid extirpation through adapting to a stressor, has been explored in laboratory systems. Our study provides the first evidence that the overabundance of deer has led to the evolution of traits that allow for compensation following browsing. This would be a case of rapid evolution. In New York State, deer numbers began exploding around 50 years ago. This is certainly within the range of years that recent studies demonstrate that evolution can occur. Our results also point to the power of replicated population studies, which can demonstrate evolutionary change as well as the potential mechanisms that plants employ to adapt to a changing environment. The evolution of tolerance over short timescales represents a previously unappreciated factor, enhancing the ability of some native plants to persist in the face of rapid ecological change.